Hello students, welcome back to the lecture number 10 on basic properties of fluid mechanics. Myself Praveen Yadav, and I am going to deliver today the lecture related with the problems on viscosity. So in last lecture we have discussed about the viscosity. So today we are going to discuss about the formula of viscosity. Viscosity, it is nothing but the dynamic viscosity, and it is given by the that is according to Newton's law of viscosity. Tau is directly proportional to du by dy, where du is nothing but change in velocity and dy is nothing but change in distance. That is, it is the tau is directly proportional to the change in velocity to the change in distance. Now tau is equals to mu into du by dy, or where mu is called as a viscosity constant, or which is called as a dynamic viscosity. So dynamic viscosity mu can be calculated as tau divided by du by dy. Now here, as we know, tau is given as a shear stress with the formula of Newton per meter square. Mu is nothing but dynamic viscosity, it is in Newton second per meter square. Du is nothing but change in velocity, it is given in meter per second. Dy is nothing but change in distance, it is given in a meter. So by taking the consideration of all units, unit for dynamic viscosity is given as Newton second per meter square. Now it is important to know that 1 Newton second per meter square is nothing but 10 poise, sorry, it is nothing but 10 poise, and 1 centipoise is nothing but 1 by 100 poise. Now poise is the another unit which is used for the showing the viscosity, because many times in many applications viscosity is shown in a poise format only. Okay, so it is sometimes to solve the problem it is required to convert in a standard SI units. So poise is required to be converted in a Newton second per meter square. So we must know the relationship between poise and Newton second per meter square, and that relation is 1 Newton second per meter square is nothing but 10 poise. Another formulas which we required is nothing but power. We all know that power is given as power is equals to 2 pi nt divided by 60, and torque here 2 pi nt by 60, in that n is nothing but speed in a rpm, revolutions per second, revolution per minute, and t is nothing but the torque, and the torque is given as t is equals to f into d by 2. So by using that equations, here it can be possible to calculate the power, and tau is given as force upon area, F by A. So these are some formulas essential to solve the problems. So du is nothing but change in velocity, that is final velocity minus initial velocity. It is again given at here. So we'll start with the first problem. A plate of 0.03 mm distance from a fixed plate moves at 70 cm per second and requires a force of 3 Newton per meter square to maintain the speed. Then calculate the fluid velocity between the plates. Now see, what is the problem? There are two plates kept on each other. The distance between two plates is 0.03 mm, that is, two plates are sliding over each other. Out of that two plates, one plate is fixed and another plate moves up forward and backward over the first plate. Now what is the speed of motion? It is nothing but 70 centimeter per second, and for that purpose the required force is 3 Newton per meter square. Now to maintain the speed of 70 centimeter per second. Now from this data we have to calculate the fluid viscosity between the plates. So here dy is nothing but 0.03 mm, f, that is force required, is nothing but 3 Newton per meter square, and u is nothing but the velocity, it is given as 70 centimeter per second, it is nothing but 0.7 meter per second, and we have to find out the value of mu, that is viscosity. Now we know that shear stress tau can be given as mu into du by dy. So du is nothing but final velocity minus initial velocity Now final velocity, as we know, 70 centimeter per second. Initial velocity, since plate starts to move from the rest, it is equals to 0. So the du is equals to 0.7 meter per second. Now tau can be given as mu into du by dy. So tau is given, it is 3 Newton per meter square. Then mu into du is nothing but 0.7 divided dy is nothing but 0.03 into 10 to power minus 3 meter. So solving this equation, we will get mu is equals to 1.28 into 10 to power minus 4 Newton second per meter square. Okay. Now consider another one problem. Two horizontal plates are placed 1.25 centimeter apart. That is, two plates are placed at the distance of 1.25 centimeter from each other. The space between them being filled with oil of viscosity 14 poise. Now here viscosity is given in a poise. Calculate shear stress in oil if upper plate is moved with velocity of 2.5 meter per second. Same problem as we solved in the previous one. Two horizontal plates placed at distance of 1.25 centimeter apart. Here the distance is more. The space between them is filled with the oil of viscosity 14 poise. Now here poise is required to be converted into Newton second per meter. Now calculate the shear stress in oil if upper plate is moved with velocity of 2.5 meter per second. That is, u final is given. So again here distance dy is nothing but 1.25 centimeter is nothing but 0.0125 meter. Viscosity mu is nothing but 14 poise is nothing but 14 divided by 10 Newton second per meter square. Then velocity of upper plate u is nothing but 2.5 meter per second. Similarly here also we are using the same formula. Tau is equals to mu into du by dy. Now du is nothing but final velocity minus initial velocity. Here mu is since initial velocity is considered as a 0 and final velocity is given as a 2.5 meter per second, so du is nothing but 2.5 meter per second. Putting these values in equation of stress, shear stress tau can be given as mu is nothing but 1.4 into du is nothing but 2.5 divided by 0.0125. So tau, that is shear stress required for the movement, is nothing but 280 Newton per meter square. 280 Newton per meter square. So by this here it can be possible to calculate the shear stress. Okay, these are two simple problems. You also try to solve in your notebook by pausing this video or putting this problem in a notebook only. Now we'll move forward to the next problem, that is, if the velocity distribution over a plate is given by u is equals to 2 by 3 y minus y square, in which u is velocity in meter per second at a distance y meter above the plate, determine the shear stress at y is equals to 0 and at y is equals to 0.15 meter. Take dynamic viscosity of fluid as 8.63 poise. Now see here, here they have given the correlationship between velocity and displacement. Instead of giving directly displacement or distance, instead of giving directly distance or instead of giving directly velocity, they have given the mathematical correlation. And what is it? U is equals to 2 by 3 y minus y square. So this equation is required to be solved by putting the boundary conditions, and for that purpose boundary conditions are also given. That is, at y is equals to 0 and at y is equals to 0.15 meter, we have to calculate the value of u. And here the viscosity constant is also given as 8.63 poise. Now here, to solve this problem, initially we have to take the derivative of above equation with respect to displacement y. If you take the derivative with respect to y, then it will be the plain equation in terms of du and dy. So coming to the given point, given is equation u is equals to 2 by 3 y minus y square. mu is equals to 8.63 points is nothing but 0.863 Newton second per meter square. Now tau is equals to mu into du by dy at y is equals to 0 is that value we wanted to find out, and tau at y is equals to 0.15 we wanted to find out. Here the equation is u is equals to 2 by 3 y minus y square. As we discussed previously, we have to take a derivative of it with respect to y. So derivative of u with respect to y is nothing but du by dy is equals to 2 by 3 derivative of y with respect to dy is equals to 1, and derivative of y square with respect to dy is nothing but 2y. So it is nothing but 2 by 3 minus 2y. So du by dy can be given as du by dy is equals to 2 by 3 minus 2y. Now at y is equals to 0, putting the value in above equation, du by dy can be given as du by dy is equals to 2 by 3 minus 2 into 0 is nothing but 0. So du by dy value at y is equals to 0 is equals to 0.1667 per second. Similarly, at the second condition also, at y is equals to 0.15, putting the values of y is equals to 0.15, we'll get du by dy is equals to 2 by 3 minus 2 into 0.15. So it is nothing but du by dy is nothing but 0.0367. So these are the two values of du by dy for at y is equals to 0 and y is equals to 0.15. Now from previous calculations, these values we are going to put in these equations. So tau can be given as mu is equals to tau is equals to mu into du by dy. So it's nothing but 0.863 into 0.667. So tau can be given as tau is equals to 0.5756 Newton per meter square. Similarly, for second equation, at y is equals to 0.15 meter, it is given as tau is equals to tau of y at 0.15 is equals to 0.3167. So these two values we are going to use for solving the these are the two solutions for the above equations. Now we'll move further for the last problem of today's lecture, that is at a plate of 50 mm diameter, a 50 mm diameter shaft rotates with 500 rpm in a 80 mm long journal bearing with 51 mm internal diameter. The annual space between the shaft and bearing is filled with lubricating oil of dynamic viscosity 1 points. Then determine the torque required and power absorbed to overcome the friction. Now this is the problem related with a shaft and bearing connectivity. Now in this problem, given diameter D is given as 50 mm, length of shaft is nothing but 80 mm, and diameter of shaft is nothing but 51 mm. Now convert all those entities into meter initially. Then speed of shaft rotation, n is equals to 500 rpm, mu is equals to 1 poise. So by putting these values, we wanted to find out the torque required and power absorbed to overcome the friction. Now initially we know that power P is given as P is equals to 2 pi nt divided by 60, as early initially in the lecture we have discussed that. Then from that we know that how to calculate torque. Torque T is nothing but F into D by 2. So for that purpose it is essential to find out the force. Now force, we know that tau is equals to F by A, force per unit area. That is also we require to calculate. And we know that how to calculate tau, because tau is nothing but mu into du by dy. So with this cycle we want to solve the problem. Initially we wanted to, it is required to calculate the tau, tau is equals to mu into du by dy by using that formula. Then we have to find out the force by using these equations. Then force is put out in a torque, and now torque is put out in a power P. So by this cyclic process we have to solve the problem. So how to calculate du by dy? So dy is nothing but the distance gap or gap between the two rotating surface. Now we know that here it is given the diameter of shaft D is equals to 51 mm. Internal diameter, sorry, journal bearing diameter is 51 mm and diameter of shaft is 50 mm. So dy is nothing but difference between journal bearing diameter and shaft diameter divided by 2, so that we will get the difference between each wall. So dy is given as d minus d by 2. How to get next quantity, that is du? It is nothing but final velocity minus initial velocity. So here's initial velocity is considered as u is equals to final velocity u is given as u is equals to pi d n by 60. Here n value is given, diameter d is known to us, so by that it can be possible to calculate the final velocity. Initial velocity, initially it will be considered as an equals to 0. So to solve this problem, initially we will calculate dy, then u, then from du by dy, then tau is equals to u into du by dy. Then we are going to calculate next point, that is tau is equals to f by a, then torque, and finally power. So by this sequence, initially we will calculate dy, it is nothing but d minus d by 2 minus 0, because du initial velocity is equals to considered as a 0. So final velocity, distance between the two shaft, it is given as a dy, and it is equals to d minus d by 2. So 51 minus 50 into 10 to power minus 3 by 2 is nothing but 0.5 into 10 to power minus 3 meter. It is nothing but the gap between shaft and bearing. Now initial velocity, final velocity u is given as pi d n by 60. So putting these values, you will get 1.309 meter per second. Now du, we know that final velocity minus initial velocity, and it is given as 1.309 meter per second. Now we wanted to calculate tau. So tau is given as mu into du by dy. So putting the values of mu and du by dy, we will get tau is equals to 2.618 Newton per meter square. Now mu, from this it can be possible to calculate the force. So force is given, tau is given as f by a, so force can be given as tau into a. So it is nothing but tau into a is nothing but that length into diameter of the shaft, that is peripheral area of shaft. So periphery is given as pi d into L. So it is nothing but 261.8 into pi into diameter is 51 into 10 to power minus 3 into 0.08. So it is equals to 3.35 Newton. Now we move further for the torque T. Torque T can be calculated as T is equals to F into D by 2. So T can be calculated as 0.08 Newton per meter. And from the calculated torque T, power P can be calculated as P is equals to 2 pi nt divided by 60. So it is given as 2 pi into 500 into 0.0822 divided by 60. So it is given as 4.304 watt. So in this problem, I think we have covered all formulas related with equations, and here we end with the lecture. In next lecture, we are going to see the next fluid properties. Thank you very much.